Hi everyone, Mrs. Venti here. Welcome back to my channel. In today's trigonometry video, we are going to do exercise 2, which is found on page 165, 166 of the Mind Action Series Grade 10 textbook. Before we get started, please like and subscribe so you get all notifications that are necessary for the new videos. So in this video, we are going to answer 10 questions. Exercise 2 has got 8 questions, but before we get to that, we are going to do 2 examples. What's different in this video or in this section of trigonometry is today we are going to learn how to use the calculator in answering trigonometric questions. Example number 5, which is found on page 164, gives us the triangle UVW. We can see that UV is 12 units long. Angle V is 35 degrees and angle W is 90 degrees. Now in the past we had more information, but right now we only have one length and 2 sides. How do we go about answering this question? Example 5 asks us, what is the length of VW? So if I was going to mark it, I would mark it in yellow. That is VW. How long is that? And what is the length of UW? How long is that? We are going to use trigonometric ratios to figure this out. So, in order to answer question A, because already I said we're going to use trigonometric ratios, we know that trig ratios have to do with the names of the sides. So I know that this length of 12 is known as the hypotenuse, and it's the hypotenuse because it is opposite the 90 degrees. Since I'm using 35 as my reference angle, my 35 degrees is made from the hypotenuse and the yellow line. The yellow line is called adjacent because it's right next to my 35 degree. And the line that is opposite, the green one, is called opposite. So now, what this question is asking me is, what is the length of the adjacent side? Now I've got adjacent is what I am being asked for, so it definitely needs to be in my trig ratio. And what I do have in the question is that 12, that is the hypotenuse. Adjacent over hypotenuse, when written down like that, automatically you have a light bulb going off saying ding ding ding, adjacent over hypotenuse is cos. And remember, all of our trig ratios have a relationship with an angle, so it's cos of 35 degrees. Cos of 35 degrees is equal to adjacent over hypotenuse. Now I'm going to substitute values and I'm going to say adjacent over hypotenuse is 12 is equal to cos of 35 degrees. Now that I have that, I am going to use basic rules of equations to move this 12 to the other side. I'm going to say times 12 here, these two cancel out, and times 12 over there. I'm putting it in front of my cos sign. So my new equation says adjacent, which is what I want, is equal to 12 cos of 35 degrees. At this point, we are going to use our calculator to solve this question. So most of you have this calculator. If you don't have the exact same Casio, it's okay. The steps will be more or less the same. In order to get the answer, we are going to input the values exactly the way we wrote it down, right? So we are saying 12 cos 35. I'm going to input the numbers 12, 1 and 2. Then I'm going to go to the words or the black buttons, and I'm going to find the word that says cos or cos. Then I input the value of the angle, which is 35 degrees. You can close the bracket, you can leave it open, you'll still get the same answer, and then you press equal. So now our answer is actually 9,829824531. That is the complete size of what the calculator would output for you. But our answer is required to be in 2 decimal places. So if I say adjacent, which is actually VW, is equal to 9,829824,531. I need to correct this to 2 decimal places. 2 decimal places would be 1, 2. 2 to the right of the comma. Quick reminder, how do we round off? You are going to use the Hill method, and it says that if you have a number between 0 and 4, then it stays the same. If you have a number that's 5 to 9, it goes to the next number. So which number do you use when you look at the Hill? You look at the number next to the decimal place you want to stop at. So we're going to look at the number 9. 9 says go to the next number. So now that we know we're going to the next number, it means you go back to the 2, and the 2 becomes a 3. So VW is actually equal to 9,8, and that 2 becomes a 3. This is your answer, correct to 2 decimal places. Let's answer question B. Question B is asking you, what is the length of UW? So we've calculated, I wrote this in the wrong place. UW is going to be the green one. VW is 9,83 from our previous calculation. Now you've got 2 options. Your first option is to use the method we used in the previous slide. So over there we have got using the trigonometric ratio in order to calculate UW. Your other option is, because you have 2 sides, you can use Pythagoras. So if we were to use Pythagoras, we would say, according to Pythagoras, if you have a 90 degrees angle, then you are able to use the rule of Pythagoras. So Pythagoras says side squared plus side squared is equal to hypotenuse squared. Let's substitute values. UW is the one we don't have. I'm going to write it like that because I want you to be able to see different ways of writing values. So UW squared plus side is going to be 9,83 squared is equal to hypotenuse, which is 12 squared. So I am going to say UW squared is equal to 12 squared minus 9,83 squared. UW squared is equal to, let's use our calculator for this. So we're going to say 12 squared gives me an amount of 144 minus 9,83 squared gives me an amount of 96,6289, 96,6289, 96,6289, and then I subtract. So I'm going to say 144 minus 96,6289 gives me an amount of 47,3711. UW squared is 47,3711. Now, in order for me to get UW alone, I'm going to square root this side, and what I do on the left, I do on the right. So UW is the square root of 47,3711, and I input that as square root of the answer, and that gives me 6,8826666. 6,8826666 dot dot dot. Again, my question says 2 decimal places. So as 2 decimal places, I'm going to say UW is equal to, let's do the decimal places again. 2 decimal places is there. I look at the next number. 2 says stay the same. Go back to the previous one. 8 stays the same. So my answer is going to be 6,8, and the 8 stays the same. So that is using Pythagoras to answer the question. We can do the exact same question, but answering it using the trigonometric ratio. I'll show you that now. So if I wanted to use the trig ratio, remember in our first slide, we said that this yellow one here on the bottom is adjacent and the green one was opposite. So let's label them. This is adjacent and the green one is opposite. So what are we looking for? We are looking for opposite and what we have. Now in an instance like this, I will always use what they give me before I would use what I have. So they give me that 12. I'm going to say opposite over hypotenuse. Opposite over hypotenuse, ding, ding, ding. Yes, that is sine of 35 degrees. So my opposite stays the same. Over hypotenuse is 12 is equal to sine of 35 degrees. I am going to say opposite is equal to 12 sine of 35 degrees. Quick recap, what did we do? We said times 12 to cancel the denominator and times 12 on this side. But I put the 12 in the front of my sine. So opposite is 12 sine of 35. Let's bring out our calculator. 12 sine 35 gives me a total of 6,8829172336. So my answer is going to say opposite, which is actually named UW, which is what the question is asking me, is equal to 6,8829172336. I want this to 2 decimal places. 2 decimal places is there. I look at the next one. The next one is 2. 2 says stay the same, so 8 stays the same, which means that UW is equal to 6,8, and this 8 stays the same. That's my final answer. Now let's compare the two answers. Using the trigonometric ratios, we get an answer of 6,88. Using Pythagoras, we get an answer of 6,88. So exactly the same answer, 2 methods. Okay, example 6 is asking us what is the length of AC? That is this line that I'm drawing in orange to 1 decimal place. We are only going to use trig ratios, so we are going to say, how do you want to do this? We are going to say, first you need to know the relationship to this 53, so we can see that it is adjacent over, what do they give us? They don't give us hypotenuse, but they give us opposite. Adjacent over opposite. Oh, lo, 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 lo. Oh, lo, 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 lo. Now what are you going to do? We want adjacent. So what is adjacent over opposite? I have not yet taught you this. So instead of doing adjacent over opposite, let's use what you know. Okay, we'll come back to that later in the year. Let's say we do opposite, because you know this one, over adjacent. Opposite over adjacent is tan, right? So tan of 53 degrees is going to give me opposite over adjacent. Let's substitute values. We know that opposite is 7. 7 over adjacent is going to give me tan of 53 degrees. So I want to get adjacent alone. What do you want to do that? First, I'm going to multiply by adjacent on both sides, because adjacent is a denominator. I want to get it away as a denominator. So now I have 7 is equal to tan 53 times adjacent. Now I'm going to get rid of tan of 53, and I'm going to say divide by tan of 53 on both sides. So this means that I have got adjacent is equal to 7 over tan of 53 degrees. Now I can bring out my calculator. So I am going to input into the calculator 7 divided by 10 of 53, and that gives me a total of 5,2748. 5,2748. So this is going to be equal to 5,2748 dot dot dot. Now, I didn't round off properly, but what I'm going to do is I am going to answer. They're saying 1 decimal place. This is 1 decimal place. I look at the number next door, which is 7. 7 says go to the next number, which means 2 changes to 3. So my final answer is going to be adjacent is actually AC, right? AC is equal to 5,3 meters rounded off to 1 decimal place. That's how you answer this question. All right, so let's get into exercise 2. We went slow for the examples. Now we are going to go much faster. Question A1 is telling us solve for x to 2 decimal places. So for all of question A, we are going to solve for x, all of the answers to 2 decimal places. I have got x is adjacent. X is adjacent, so I've got adjacent over hypotenuse, which is adjacent over hypotenuse. That gives me x over 8, and x over 8 is actually equal to adjacent over hypotenuse is cos of 25 degrees. Now I am going to multiply by 8 on both sides, so that cancels out here, and I have x is equal to 8 cos 25 degrees. I whip out my calculator and I put in there 8 cos 25. That gives me 7,25046. Now I want to go to 2 decimal places, which means I am going to go to 2, 5. I look at the 0, which is next to the 5. 0 says stay the same, so my answer is going to be 7,25. X is equal to 7,25 units, whatever the units may be. That's my final answer. Question A2, same question, solve for x. What do you see? You see that x is opposite, so I've got opposite over, what do I have? Hypotenuse. Values for that is going to be x over 11. Opposite over hypotenuse is sine of 48 degrees. Okay, so now that I know I've got sine of 48 degrees, I am going to multiply by 11 on both sides so that this and this cancels out. X is equal to 11 sine of 48 degrees. Whip out my calculator. 11 sine 48 is equal to 8,17459. I want 2 decimal places, so it's 8,17. 4 says stays the same. 7 stays the same, so it's 8,17. X is equal to 8,17 units. Question A3, solve for x. X is opposite the angle, and I have adjacent as well. Opposite over adjacent is equal to, we have x on the top and 4 at the bottom. Opposite over adjacent we know as tan. So tan of 63 degrees is x over 4. Now I multiply by 4 on both sides, and I do this to get rid of the denominator. So x is equal to 4 tan 63 degrees. Whip out your calculator. 4 tan 63 is giving me 7,850. Now remember, we're doing 2 decimal places. So after the 5, I have a 0. 0 stays the same. X equals 7,85. Next question. X is opposite over 13 is hypotenuse. That is x over 13, which opposite over hypotenuse is sine of 58 degrees times 13 on both sides. So these two cancel out. X is equal to 13 sine of 58 degrees. Calculator says 13 sine 58 equals 11,024. 4 says stay the same, 11,02. X is equal to 11,02. Now we're going to answer question B. Question B says solve for AC to 1 decimal place. All right, so AC is this one, which is adjacent. And I have got, oh, I am wrong. AC is this one, which is opposite the 90 degrees, so that makes it the hypotenuse. And I have got the other value I have is opposite. So I'm going to write opposite over hypotenuse, which gives me the values of opposite is 6 over hypotenuse, which is AC. Opposite over hypotenuse, you know as sine. So sine of 42 degrees. Sine of 42 degrees is equal to 6 over AC. Now, in order for me to get AC alone, I am going to multiply by AC on both sides. So those two cancel out, and that becomes AC. So now I've got 6 equals AC times sine of 42 degrees. Now, again, I want AC alone, so I'm going to divide both sides by sine of 42 degrees. So I have AC, which technically is on my right hand side, is equal to 6 over sine of 42 degrees. I can input that into my calculator. So I can say 6 divided by sine of 42 gives me 8,966. I want to go to 1 decimal place. So since I want to do 1 decimal place, I want to look at that 9. I look at the 6 next to the 9. It tells me to go to the next number. 9 becomes 0 and 8 becomes 9. So to 1 decimal place, AC is equal to 9,0 units to 1 decimal place. Question B2. I am again calculating for AC, which is this one. AC is adjacent over opposite. We don't know adjacent over opposite, but we do know opposite over adjacent. So opposite over adjacent is going to be 3 meters over AC, and that gives me tan of 32 degrees. Or tan of 32 degrees is opposite over adjacent. I want to get AC alone, so I'm going to multiply by AC on both sides. These two cancel out. So I have 3 meters is equal to, let's take the meters away, just to not confuse you. 3 equals AC tan of 32 degrees. Now we are going to divide by tan of 32 on both sides because we want to cancel that out. So we've got AC is equal to 3 over tan of 32 degrees. Calculator says 3 divided by tan of 32 gives me 4,801. I want one decimal place, so I am going to say 4,8. Look at the next number. 0 says stays the same. AC is 4,8. 4,8 units long. Last two questions. C1 asks us to calculate PQ. So PQ is this length here. That is our hypotenuse. And in this question, they're giving us adjacent, and they want 3 decimal places. So I'm going to say adjacent over hypotenuse is equal to, you know, adjacent over hypotenuse as cos. Cos of 29 degrees, which is adjacent is 15 over hypotenuse, PQ. Okay, so in order to get PQ alone, I am going to multiply by PQ on both sides. So PQ cos 29 degrees is equal to 15. So that and that cancels out. Now I'm going to divide by cos of 29 on both sides. So PQ is equal to 15. That and that cancels out. It's gone. 15 over cos of 29 degrees. Calculator says 15 divided by cos of 29 degrees gives us 17,1503. Now I want 3 decimal places. 150, 0 is the third decimal place. I look at the next number, 3. 3 says stay the same, so it's 17,150. PQ is equal to 17,150. Correct to 3 decimal places. Last question for this video. Solve for PQ, which is this one. Technically that's adjacent to 3 decimal places. They give us adjacent, we're asking for adjacent, and they give us opposite. So adjacent over opposite, you don't know, but you know opposite over adjacent. Opposite over adjacent is actually tan of 73 degrees. And tan of 73 degrees, when we change the values, opposite is 10 centimeters over PQ. We want PQ alone, so we multiply by PQ on both sides. This and this cancels out. So PQ tan 73 is equal to 10. Now I'm going to divide by tan of 73 on both sides, and that is because I want this and this to cancel out. So PQ is equal to 10 over tan of 73 degrees. Now I can use my calculator, and I can say 10 divided by, 10 divided by tan of 73 gives me a total of 3,075306. I want 3 decimal places, so I've got 057, that's 3. The next number is 3. 3 says stay the same. 3,057. PQ is equal to 3,057. Now, notice that when we are rounding off, you need to make sure that your answer is to the correct amount of decimal places. That will affect how your question is marked. This brings us to the end of today's video. I hope that this helped you. I hope you understood. Please like and subscribe. Thank you for watching, and I will see you in class. Take care. Bye-bye.